Well, hello, everyone. Good morning, good afternoon, good evening. We are very pleased to welcome you to this week's session of UNICEF's webinar series on data collection. It's organized by the Data and Analytics section here at UNICEF headquarters. My name is Archana Dwivedi, and I work with the data collection unit here. And this is the fourth webinar after we resumed the series in April. Today's webinar is entitled Creating a Better Future with Drones. The presentation today will discuss how one can access and use drone data, highlight some of the challenges and opportunities of data collection with drones, and present use cases from around the world. We are very happy to have Helena Samsioe, who is with us today. She is the CEO and founder of GLOBHE, a tech company on a mission to create a better future with drones through the world's first Crowddroning Platform. Helena is a firm believer that the future of possible is already here and passionate about using innovative technology and collaborations to show it. Helena has been named one of the world's top 50 women in tech by Forbes. She received Swede of the Year Innovation Award in 2020, named among the top women to watch in the drone industry, and has been featured as the drone queen on BBC. Previous to founding GLOBHE in 2015, Helena worked in different managerial roles in the United States, Scandinavia, and in Sub Saharan Africa. She has been part of developing and implementing innovative change on a global scale. So we're very excited to have her here and have her present during this webinar. But before we begin, some housekeeping rules. And one of them is that we have scheduled about an hour and a half today, with the presentation followed by Q&A, and my colleague Attila Hansioglu, who will be chairing that Q&A and facilitating that. As always throughout the webinar, please remain muted and kindly write your questions on the chat box, and we will try to group them and ask Helena to respond to those questions. The webinar is being recorded today and will be available on our SharePoint together with past webinars. We also hope to have this publicly available for those who are do not have access or UNICEF staff members. So Helena, over to you. The floor is yours.
Thank you very much for that kind presentation. I'm very happy to be here with all of you today. Like mentioned, my name is Helena Samsioe, and I'm the founder of GLOBHE. I did start GLOBHE 5 years ago, and there has been quite a lot of development in the drone sector throughout these past 5 years. So I'm here to share some of those with you. I'm assuming that we probably have quite a bit of a difference in experience with drones throughout the audience that's watching. So I'm hoping there will be a little something for everyone in this presentation. It will be quite basic, but I will also try to go into some details, and then obviously we will utilize the Q&A session towards the end to try to answer the questions that you didn't think were covered throughout the presentation. So obviously we're here today to discuss data, and the drone is obviously one tool to get a hold of data, to some extent a new tool to get a hold of data. If we compare to some alternatives to drones when it comes to collect data, and to clarify in this webinar, we will be talking about data in terms of image data, so imagery data. But the alternatives to collect data with drones are primarily to collect them or use satellite imagery to get a hold of the image data, or to use traditional aircraft basically to collect the data, or human collected data, or with cell phones or other type of mobile devices to collect data. So the drone is one of many tools, and in most cases it's not the complete tool to analyze data with, but it can become one of many tools that you collect data with. Just to walk you through some of the main reasons for why drones are being seen as one tool to collect data and as a complementary tool to collect data is many times that when we compare it with satellite data has a much lower image quality. So in most satellite data or open satellite data sets, we usually see between 50 and 100 centimeter image resolution. And what that really means is obviously that it's great for certain use cases, but if you need to see a little bit more of details within the imagery that you're analyzing, then potentially that's not the best solution for you. And that's where drone can come in and make a difference, where we see that most of the imagery that drones capture, they can go down to even being 1 centimeter resolution. So that means that the drones that are being flown around the world and are being flown through the GLOBHE crowdroning network, but also being flown in general, they normally have cameras between 12 and 20 megapixel cameras on. They normally have drones with 12 to 20 megapixel cameras on them, so that they can capture this high quality image data and basically, be able to zoom in about 50 times more on a drone image compared to satellite imagery, which obviously means that you can get even more detailed information from these type of data. And another reason for why drones are being used as a tool to collect data is that we see that most of the satellite data, at least when we do compare with open source satellite data, it lags in time. So a traditional Google Earth or Google Maps, they lag between 14 days up to 2 years. So if you are going to monitor sudden onset changes, it could be natural disasters or it could be community development over time, you might not get the latest data, or you will not get the latest real-time data if you use satellite imagery. And this is obviously where drones can come in and help fill that gap by collecting image data in real time, and by doing so making more recent changes visible. And of course, we also have some issues when it comes to satellite data with the fact that some of the data captured on cloudy days are not usable. So there's a lot of data that's being lost in that sense. And when it comes to drones, they're obviously flying under the clouds to collect that data to avoid that type of issue. If we move away from satellite and we talk a little bit more about airplane data and aircraft data, they come in really handy if you're going to cover large areas, but they are quite expensive. And as we also are living in a world that's becoming more environmentally concerned and informed, we also know that it's not the most environmentally friendly way of collecting data. So drones have the potential both to reduce costs quite heavily by 48% approximately, but also, since most drones out there today are battery driven, we are only using battery driven drones within GLOBHE and our network of pilots around the world, and of course there are also gasoline driven drones, but the majority of drones out there are battery driven. And then if we compare it to humans collecting data with cell phones or other type of portal cameras, it is obviously quite a slower process, especially since you have to, you cannot get the same, you don't get the same helicopter view, so to say. You will have to move around to many different places, and it's more limited in terms of what you actually can capture under a certain time frame. We also know that in some environments, it's not ideal to send a human. And obviously one of the use cases that I will talk a little bit more about throughout in this presentation is the use of actually climbing certain type of infrastructure, such as telecom towers. That we know that it's quite dangerous job, and we know that humans are in many places around the world climbing telecom towers to inspect them, for instance, and that is also resulting to a lot of injury and even deaths. And obviously, by sending up a drone, sending a drone up the tower instead of sending a human up the tower, obviously reduce the risk of fall accidents. And the same could be if you send a drone into a contaminated area or an area with explosion risk, or in other type of dangerous areas where you don't like humans to be. Then obviously, it's in most times the better scenario is to send a drone instead of a human. So these are some of the scenarios where drones are being used, and where they can make a difference. Obviously, if your use case and your need is not up-to-date recent data. If your use case doesn't require that, or if you don't require detailed analysis of the data, it's okay that you can utilize satellite imagery, which also do give a lot of details in many ways. Then obviously drones might not be your alternative. But in the cases where you are, then this could be a really great complement. So to walk you through then, obviously this is more for like illustration purpose. So just to give you a little bit of a difference, satellites are usually 50 centimeter resolution imagery. So if you zoom in quite a lot and you want to see details, it becomes quite pixel filled and it's hard to see. And with aircraft, you can get down to approximately 25 centimeter resolution, which obviously gives you a much better view. But obviously, a drone can go that even further and reduce the image resolution quality and enhance the insights being able to attract from these type of imagery. Because at the end of the day, that's what it's all about: is gaining information from these type of imagery. And to show some real life examples of what it can look. We have Google Maps here in the background, and this is when our drones are out capturing and monitoring agriculture crops. If you were to determine the current status using Google Maps, you will see what's in the background, and using a drone, you will see what's the green field. So you will actually see what it looks like in reality. And here's another example of obviously that you can also use the imagery that the drones capture, and you can stitch them together and you can form different type of outputs using like 3D imagery and so forth. This could obviously be useful for quite a lot of different scenarios. And we do know that since satellite imagery are many times lagging in time, we do get sometimes referred to as black holes, where you cannot really see anything at all, or you can see very limited in terms of what reality actually looks like. So it's a great complementary tool in those cases where that type of more recent information is needed, and especially if we look throughout many of the African countries where quite a lot of things happen in short time. If you are looking at imagery that's outdated, you are likely to miss quite a lot of developments that have actually happened in these societies over the past months or even up to years sometimes. So that was a little bit of a background of, obviously why drones come in handy. And one of the reasons for why I started GLOBHE back in 2015 is that I was flying drones for fun back then. I used it mostly as a great tool to be able to capture beautiful aerial imageries, but I also soon realized that it's not just beautiful photos, it actually entails information, and information is data and can produce quite significant insights. But some of the issues, before I go further on that, this is just to show that obviously one image might not, show so much information, but many times, our drones collect up to 10,000 imageries, and they are being stitched together and become these, updated real-time high-quality maps where you can obviously zoom in and you can see the latest type of developments, which comes in handsful after cyclones or floodings or recent changes that needs to have an updated view from. So that's one of the reasons for why GLOBHE was started, and why we also decided to launch our web app that's today called Crowddroning. It is that we thought that it's a bit of a shame that it's hard to get a hold of these type of data. And if you are an end user, no matter if you're an NGO or if you're an international company and you are in need of that type of image data from drones around the world, it was up until quite recently hard to get a hold of that data. So that was kind of like the gap that we are trying to solve by making drone data available in a few clicks through our web app Crowddroning by GLOBHE. And to show you a little bit more how that works is that we have a network today of over 3,800 drone pilots in 84 countries. So we are never flying ourselves, so to say. We're always outsourced to local capacity, and making it possible then for our end users to order data from these locations through our web app. And this is to show you a little bit of where we're located today. This is a bit outdated. We've added 7 countries to this list, so in 84 countries. But to give you a little bit of a global scope of the uptake, and the way that it works is that our end users can order the type of image data that they want, and that could be either just the raw data, which is JPEG photos, or they also want them analyzed or stitched together in orthomosaics or 3D maps, or they might want to add thermal imagery and so forth. And they can request that data, and they can draw from what type of area that they want the drone to fly to capture this data, basically. And it's then being matched with a local drone pilot that picks up that mission and then receives a flight route on how he or she is going to fly to capture that data. And that flight route entails quite some important information in order to capture the best quality data, which obviously depends on the use case. So depending on who the end user is and what the data is going to be used for, it could be wise to fly at different flight heights, for example. So as you can see in this example, we're flying at 120 meters, and it's pretty standard height to be flied on. In most countries, that's also where the legal limit goes. And it enables you to capture high quality data, but also to be able to capture larger areas quicker, basically. And then it shows you a little bit of an estimation of the number of photos that route is going to entail, and also how many batteries that this will require using a standard drone. This is based on a DJI Phantom 4 drone, which is one of the most commonly used drones around the world. Obviously, if you would assign this to a pilot with fixed wing drone, which to those who are not familiar is a little bit more like a small aircraft, then you will be able to scale up this and do this even quicker. But we try to tap into technology that's already out there and already available, which means that we don't like to ship new type of drones to the locations where we operate. So all our local operators have their own drones, and they can fly with using that technology in most cases. Sometimes it is needed to equip with larger drones if that's not locally available. So the whole idea is obviously then for the drone pilot to collect imagery from the chosen location and then upload that to our Crowddroning platform, making it available for our clients, which they receive a URL link, a download link, when the package is ready, basically. And depending on what type of data that the client order when they place their request, either as raw data, meaning JPEGs, they will receive a zip folder with the data output formats that they required. So normally that's a mix of JPEG raw data, which is the most common alternative, because a lot of our clients, they have their own software where the data gets uploaded to. In the cases where our clients don't have that, we do provide them with the orthomosaics or 3D maps, which is usually delivered in GeoTIFF files or shape files. And the type of software that our clients utilize, and also that we utilize within GLOBHE to be able to view and analyze the data that the drones collect, are primarily one of these three that are being mentioned here. So Drone Deploy and Pix4D are the two main softwares used for drone data collection around the world today. It is a pretty complete solution where you can both plan the flight routes and you can also analyze the data within both Drone Deploy and Pix4D. And you can export different type of data formats as mentioned below here, above here. But we also do have clients that are using S3 or ArcGIS, and then we also have clients utilizing QGIS. And out of these alternatives here, it's only the latter, QGIS, that's completely free. So you will have to have paid subscription plans for the other ones. But QGIS is a free program available to view different type of output formats from the drone captured imagery. So to show you a little bit of what a finished flight can look like and the output data from that, this is the view within Drone Deploy, and this is after the data has been analyzed. So basically you can see where the drone has been flying and gathering the updated imagery from. That's the green area that's overlaid on a satellite map. And the beauty of drone imagery is that each image is geo-referenced, so each has a GPS coordination. So it's possible to overlay it on satellite maps like this, meaning that you overlay the imagery and you get the exact GPS coordination of that data so that you can actually see where that data was captured from. So that was a little bit of how the data capture works and why it's being used basically. So now let's talk a little bit about who uses the drone data and why basically. So here are a few examples of end users of drone data. So it's ranging from different type of NGOs and humanitarian organizations. Primarily today, using it in disaster prevention and disaster response. We have telecom companies primarily using drone data today to inspect telecom towers. We have environmental agencies primarily using drone data today to track climate change. We have emergency response, also responding primarily to natural disasters today, but it could also be human-made disasters. We have governments who are using drones to both to collect data for the society, but also to be able to use drones as a way of transportation to deliver medical cargo. And that's obviously something that's used within humanitarian organizations and emergency response as well. And then we have agriculture companies who are primarily using drones to be able to monitor crop fields and crop outcome. Of course, there could be other users as well, but these are some of the most commonly used actors of drone data today. And I will give you a little bit of insights on a few use cases that we are working on or that we have been working on over the past years. And this is quite a new initiative, started together with Liverpool School of Tropical Medicine. And the location is Malawi, where we are using drones to capture image data from lake areas in 3 different locations throughout Malawi. And the whole point of that is to help the research initiative coordinated by Liverpool School of Tropical Medicine, but also working with 3 local universities in Malawi to be able to identify if the drones are going to be an efficient tool in malaria prevention. So as probably most of you are even more aware and informed than I am, a lot of the malaria prevention efforts so far have been focusing on indoors, so being bed nets or spraying the inside of walls. So fewer initiatives have been focusing on the outdoors. So this initiative here is actually focusing on finding the ideal environments where mosquitoes are laying their eggs. And this initiative by Liverpool School of Tropical Medicine have identified visual characteristics for what these typical malaria mosquito breeding sites look like. So by starting the research initiative 3 years ago, they were able, by doing ground sample surveys, they collected a lot of water samples from different lake areas throughout Malawi, and could, by doing so, pinpoint the certain type of water samples to the typical visual characteristics. So that could be the type of vegetation, or it could be the color of the water, or it could be the level of the water movement. And by putting that all together and comparing with the samples that they've taken, they came up with a standardized for that this is the visual typical characteristic of where mosquitoes are laying their eggs. And by doing so, now are scaling up this initiative to see if drones can be used to pinpoint where the mosquitoes lay their eggs, and by doing so being able to pinpoint prevention efforts for malaria. And another use case for our drones, we've been working with UNICEF Malawi since the opening of the humanitarian drone corridor in Malawi, Kasungu, Malawi, since 2017. And some of the imagery that the drones have captured in Malawi has been both in terms of social economical mapping and disaster resilience and early warning systems, but also used in cholera response in 2018, where drones were used in a combination of AI, in this case image recognition, to be able to identify the number of households and the location of both households, water and boreholes and latrines within 8 suburbs of Lilongwe. And I will show you a little bit more how that was done. So the drones were used to capture the image data, and then based on image recognition algorithms, we were able to analyze the data by pinpointing different type of houses and different type of objects of interest for the cholera response. And in this case, that was primarily related to what type of infrastructure was present in these areas. So it was done together with UNICEF Malawi, but also the Malawi Minister of Health. And the interest there was to be able to identify the number of households in these areas, so to be able to count, but also to be able to identify if the households had tin roof or thatched roof, because that was an indicator of social economical standards, meaning that the ones with tin roofs in most cases had higher levels of sanitation, and the thatch roofs had poorer levels of sanitation, which is obviously of importance in these type of disaster response efforts, and especially obviously when we talk about cholera, which is obviously sanitation sensitive, but also used to identify public dumping sites, groundwater, wells and boreholes, so different type of water sources, since that's also a typical contamination source of the cholera virus. Another use case example that our drones are using, which I did mention before, is to obviously inspect telecom towers. It's quite an obvious use case in the way that the alternative so far has been sending a human up, and by not having to do that, both the speed of capturing the data, the quality of the data that's getting captured, and also the safety level of how the data is being captured is obviously increased. And we are doing this for a global telecom company, not allowed to mention their name, but they're operating in over 140 countries throughout obviously local telecom operators within these countries. And we are collecting data in up to 30 countries over the next 2 years, about 1,000 sites in each. And the goal of doing that is obviously to maintain and inspect telecom towers to make sure that communities are connected. And we're doing this as a regular maintenance, but also being able to do it post natural disasters such as flooding and hurricanes, where obviously these type of crucial infrastructure many times get damaged and impacted. And also we are applying our drones to monitor water pollution. This is an initiative that we're doing currently in Sweden only, where GLOBHE has our headquarters. And it's also a part of a research initiative so far only, where we do have different type of agencies and end users as part of that research. One of the end users in the program is a water purification plant company here in Sweden, and they have some issues by determining when water pollution is coming towards the water purification plant. So they're using satellite image data currently to identify when algae blooms and oil spills and so forth are getting closer to their purification plants. And when they do see that type of changes, they have to make readjustments to within the plant in order to filter the water more properly, to make sure that it's clean drinking water coming out. But they have now started to use drones as a way to, when they are seeing certain movements on satellite imagery, but it's not clear exactly what that is, they have now started to use drones to pinpoint and send drones to those areas where the information from satellite imagery is a bit limited, so be able to update the imagery and also to be able to see more clearly what's actually going on. And obviously how you access drone data today, you can do it in many different ways, and there are many suppliers nowadays of drone data, obviously GLOBHE just being one of multiple suppliers, and all our local drone companies, they also provide drone data by themselves. But by using GLOBHE and collaborate with us, obviously they get an access to other type of software and other type of reach and scale than they would do by themselves. So either you order drone data on demand from us or from any of the local providers around the world, and you can also subscribe to drone data. And this is quite interesting because we've been around for 5 years, and we're seeing that we move from a quite limited data on demand orders. Our end users are quite interested. They're quite curious and they want to test it out. But it has taken quite some time to really, understand the value and how that can help, their operations. And I would say that it's just as of last year where we're actually moving more to end users incorporating this data on a subscription or like a reoccurrent basis, and it has actually become a big part of many of our end users' operations, which is obviously a really interesting development that has been taking place over the past years. But to summarize here before we enter into the Q&A sessions, obviously our goal is, as the whole presentation today's title is, to create a better future with drones. And said, obviously, it takes time to make change happen. So you don't do it overnight, and it actually takes quite a lot of time, both on the regulatory side and also on the technology side. So we've seen many local countries have adopted now quite innovative regulatory frameworks, being especially we've seen that happen in Southern and Eastern Africa, where they have actually focused a bit more on the opportunities of this technology, but obviously by doing so also focusing on how you can integrate it in a safe way with obviously traditional aircraft. And we're seeing the United States implementing an updated framework for UAVs of last year, and as of January this year, the whole European Union came together around the same joint regulatory framework for entire Europe. So what this means is that we're going from situations where countries had no regulations in place or very strict regulations to having local regulations in place at a larger scale, which is obviously the fundamental cornerstone if you're going to scale it up and if it's going to be used responsibly and safely, and also by being integrated with traditional aircraft. So with that being said, UAV regulations still remain one of the challenges for drones, but it also becomes a pretty big opportunity as we now see that the UAV regulations are starting to become in place, and by doing so, drones are one step further of actually becoming a crucial part of several nations' infrastructure. Obviously, another main challenge to a larger sense, it's the safety and privacy concern. The drones are many times equipped with cameras and obviously collect a lot of data, which is sensitive data sometimes, and of course, just as Google Maps had quite some issues of establishing Google Maps as a global virtual marketplace where you can access detailed data. It took them many years before it was allowed to do that, and I think drones are going through the same pipeline, so to say. And it's of course very, very important that we navigate around this carefully. And also obviously how the drones fly, because obviously there are objects that can fall down from the sky, and obviously that's a safety concern in itself. So that tags along to the importance of having UAV regulations in place, where drones can be flown as safely as possible in societies around the world. And then we come to technology limitations. And that I would divide that in a few different aspects. So you will have the technology limitation in the drone itself, in terms of the range. I touched upon it briefly earlier on in the presentation, but a lot of the drones that are flown today are either multi-rotor drones or fixed-wing drones. And the difference between these two drones are that the multi-rotor drone is a small helicopter drone, looks obviously like a small helicopter with the rotors, and the fixed wing looks a little bit more like a fixed wing airplane. And the fixed wing can fly longer distances, and we are also seeing the versions of vertical takeoff and landing drones, which is a mix between the multi-rotor drone and the fixed wing drone, which can both take off and land at same place, but also being able to fly using the power of the wings, and by doing so reducing the amount of battery that's being consumed. But to just summarize a bit that shortly, most drones out there are still multi-rotor drones, and they have a limitation in reach. So being just maybe ranging from 1 to 5 kilometers in reach, where you have fixed wing drones and V2L drones that can reach, around up to 100 kilometers. So that's one limitation in itself, but we've seen quite a rapid change here over the years. And the other limitation in itself is the battery capacity. So most standard multi-rotor drones, they only have a battery capacity of around 30 minutes. Which is obviously to some extent a limitation. And then a final limitation that I would like to mention on the technology side of things is that it's still quite weather sensitive. So many drones are still not capable of operating in heavy wind or in heavy rain. And that is still a challenge. And if you're going to have a drone that can operate in these harsh climates, or they can fly at a longer range, then that also comes to a cost. So it's a fraction of that as well. So most of the time we are still seeing drones being used that are limited in both range and battery capacity, because those are the ones who are also economically feasible to use, even though we are obviously seeing expectations of that as well. I would also like to mention the knowledge gaps that there are, and that is both on the end user side, but also on the pilot side. We are seeing that if we just compare to 5 years ago, we are seeing that the local knowledge was mainly found in the US to a large extent, with obviously Europe and Asia to some extent, but we didn't have a lot of locally qualified pilots in Africa, with perhaps South Africa and Nigeria being the expectation. But we've seen a lot of regional and local initiatives, both in Europe and in Africa over the past years, where local capacity has been trained. And now I would actually say that we have some of the most qualified drone pilots and most experienced drone pilots in Africa. And I think that the reason for that is that they are actually also working in countries where governments have taken a very innovative approach and actually started to use drones and allow them to be flown. So I think that this is quite a tremendous development that we've been seeing over the past just few years here. So that's quite exciting. And then obviously we are also seeing that change takes time. So even though we do know that this is possible, and we have a technology here that can do a lot of great things, even though there are limitations, it takes time to change. So every innovation takes time before it becomes implemented and before it becomes used at scale, basically. So I would like to leave the presentation with that, and saying that we are at least on the way towards creating a better future with drones, but obviously there is still much work to be done in that aspect. So thank you very much for listening in, and I am here to answer any questions that you may have.
Thank you so much, Helena, for an excellent presentation and an overview of drones and how it's being used and for its future use. So I'll turn it over to Attila to facilitate the Q&A. Thank you.
Thank you very much, Arjuna, and thank you so much, Helena. This is fascinating, really. It was a joy to listen to you presenting this. We have a few questions and comments in the chat box. I will go through them.
Yes.
I think you may have had a chance to glance through a few of them.
No, I haven't seen them at all.
Okay.
So yeah.
Okay.
So
I will start in order in order with which they were put in there.
Yeah.
First one was a comment.
Yeah.
Just to say that the satellite data lag on Google can be compensated by requesting specific satellite images from Unitar Unosat. Unosat was one comment. I wonder if you have any comment in relation to that.
No, and that's very, very much the case, and that's why I said that mostly this is speaking towards satellite imagery that's open source and available, but of course there are non-open source options, and to some extent also open source, which can be requested. But still, we do have the issue that it's in most time not real time, or if it's close to real time, then it actually adds up and become quite expensive. So I think it's good to know that satellite imagery is not always available for free, even though sometimes it is, and sometimes it satisfies the needs, and sometimes it does not satisfy the need, basically.
Thank you, Helena. Actually, in relation to that, you said towards at the beginning, the first slide, I think, or the presentation, that there's a time lag when it comes to satellite imagery compared to drones. Can you explain that a little bit further? Why there's a time lag?
Well, I think if I don't know if I'm guessing most of us have tried to Google our house on Google Earth maybe at one point, and you can maybe see that there is actually snow outside, even though you enter the street location of your house in the middle of summer. So satellite imagery are not being taken every day, and they're also not being updated every day. So that is the main concern with that. Obviously, there are other formats where that's happening, but that's also when it becomes maybe doable to get them from Stockholm or from New York, but maybe not so doable to get them from Kazungo, Malawi, for instance. So it depends on a little bit where in the world you are, and also the use case of how you need it, and if also the cost that you are willing to pay for it, basically.
Yeah, and compared to drones, of course, if and when you fly the drones and get data, that's real time. But that's dependent on if and when you fly the drones, obviously.
Absolutely. So I mean, it depends on if you have a local drone operator in that area, then obviously you can send out that local drone operator and capture the data when you request it. So yeah, that's what I meant with the real time option there. So you can make it in real time, but you can also customize it, because sometimes maybe you just don't want the top-down approach. Maybe you need to circle around an object, or you need to take other forms of views that might not be seen on satellite imageries, and that's obviously something that drones can they can customize the data output for the end user, basically.
Mm-hmm. Okay, one comment and question: are the AI available to use in other projects? For example, if you want to detect mosquito eggs in other parts of the world, that was a fascinating example a use case that you gave.
Yeah.
And can you explain a little bit more about how the breeding grounds of mosquitoes are detected through drones?
Yeah, absolutely. So I think the question has two components in it. So one is if you can apply the AI to multiple use cases, and the answer to that I would say is both yes and no. So the reason for why I say no is that if it's not already available, you need to train the data sets first, and you need to train the artificial intelligence to recognize a new type of feature. So in this example that I've shown, the algorithm was trained to recognize houses, roads, and water. So with the mosquito breeding site project, we have not yet trained it to detect mosquito eggs. That's something that might be added towards to the project as we go, but now it's mostly used as a way to identify the environmental characteristics. So with that being said, to find the lake areas that have more grayish water than blue, and to find the lake areas that have semi-water movements. It cannot be very well if you're on a mosquito and you prefer to lay your eggs, you don't want water movement. You want pretty still water bodies. And you want it to be semi-vegetation. You don't want it to be filled with vegetation, but you also don't want it to be without no vegetation, basically. So if you have these type of visual characteristics, then that means that that's a typical, that's a preferred site for mosquito eggs. And those are that's the data that we give the researchers now, so they can, based on those visual characteristics, determine how many lakes have these type of visual characteristics and how many lakes don't have that. But AI is obviously a way to add to the project where you can make that type of analysis more automatic. So I think that could be a really neat added on. But when it comes to AI, it still has a lot of training to do, which also at the end of the day still requires human input to some extent. So it's not widely deployed for any type of use case, but it could be trained and it could be applied. So that's basically the long and the short answer to that question.
Thank you, Helena. When this type of data is created, either with or without AI with it, does it come with uncertainty bounds as well?
Sorry, can you uncertainty bounds? What that is?
What is the probability of not being accurate? In other words,
exactly. So in the case, I would say that most AI that's out there today, probably, it's hard to say that it has one specific accuracy. In the case that we used, we had accuracy rate between 78% and 93%. But I think it's hard to say in general what the accuracy rate is. But yes, that's something that we would be supplied if the data sets are being generated and provided to the end user. Something that we're seeing, I mean, we know that Google and IBM Watson, for instance, they have deployed their visual algorithms to the sense that you technically could upload an image and IBM Watson can tell you what he sees. And that works very well if you upload imageries from Europe or from the United States. So let's say that you will upload an image from a house in Stockholm, Sweden, for example. Then that IBM Watson will most likely tell you that it's a house. And it will base that answer on that the ceiling usually have a certain type of quality, maybe brick, and the road that the house is located next to is usually paved. But if you would upload a house with a thatched roof on a mud road, it will not tell you that it's a house because it has not been trained and fed on those type of data. So that's a typical example of where technology basically works for what and why it's been trained. So I would not call AI inclusive today. I would call it quite selective today still.
Thank you, Helena. One area where drones are being used increasingly, I think, will be used. That's my guess, and is in relation to household surveys, especially the sampling part. And one comment here is in relation to that issue. Considering listing and mapping activity of household surveys, where before we select the sample households, we have to have a mapping and listing of the households, obviously, where we update census enumeration areas mainly. Is it possible to upload the enumeration area boundaries to drone as to get updated aerial maps for given areas? Moreover, are there any software for drones to recognize multi-floor structures or type of structure from 3D views instead of 2D bird eye view?
So I'm not completely sure that I'm following the question completely here. So I will go ahead and give it an answer based on the components that I understand. But yes, in most cases when we do fly for household surveys and similar, the output that the end user is normally looking for is 3D. And that is to be able to determine multiple layers of floors, but also to be able to do certain type of measurements. So that is doable to do. I'm not sure. I think it was another component to that question that I didn't really fully grasp.
I think the question is in relation to this. When a household survey is being implemented, we need to have a mapping and listing of households within a certain enumeration area, which would come with GPS coordinates.
Yes.
Which would have already GPS coordinates. Is it possible to upload the boundaries of that enumeration area to the drone?
Yeah.
So that the drone knows where exactly it would be looking at to map and list the households within that area.
Yeah, absolutely. So so basically what you can do is you can upload an existing layer of information that has been captured not using drone as a text file or a shape file into some of these drone softwares like Drone Deploy, for instance, that was mentioned. And then you can overlay that view with the drone view, so to say. So you can get a sense of how well is the different type of data sets complementing one another. And to some extent, that was being done with the AI example that I showed, where we were using AI to determine boreholes and latrines and so forth. That was actually matched with also ground sample data that could confirm that these were actually the GPS positions of these type of objects. So yes, you can overlay different type of inputs, and especially I think even more so in the program that's called ArcGIS or Esri, because then it allows you to upload different type of data sets, and by doing so getting a more comprehensive view for the final output, basically.
Thank you, Helena. One of my colleagues is pointing out to the fact that we actually tested this in Malawi. When I say this, the use of it for mapping and listing of households for household survey.
Yeah.
And we were somewhat disappointed from the test. Extremely heavy graphics, but still, of course, future potential in this.
What was it was a disappointment in terms of I didn't really get it.
I think the comment is that it was extremely heavy graphics.
Graphics, yes.
Yeah.
Yes, that's actually good. I should have mentioned that as part of the challenge, because the thing is, obviously, the good thing about drone data being the high quality that it is obviously the large amount of information that you can get. The negative part is that the files of a drone map is huge. So it means that it's heavy in the sense of if you're in an environment where you have limited connectivity, the transfer of the files and the time it actually takes to upload and analyze the data, it could be quite long. And I'm assuming maybe that was what that comment related to.
I think so, yes. Thank you. Thank you very much.
Yeah.
Another question, what are the main sources of data used for validating AI algorithms? How often is this done?
Yeah, so the main is a little bit that what I was saying before. It's to compare it using ground samples. So you need to know obviously what the you need to have a cheat sheet, so to say. You need to know at least initially you need to know what the reality is, and then you can apply AI to it. So you need to have at least one survey made that's not AI applied, so that you can check AI results. But if you do have one, and if you want to monitor change over time, for example, then you can apply AI to do the monitoring over change. But you need to have a cheat sheet in the sense that you need to know what the reality is from one certain point in time, basically.
Yeah. Okay. I think Bo is indicating the heavy graphics or the size of the data. And he's saying for an enumeration area, it can be a 2 GB 3D picture that can be collected.
Yeah.
Okay. Just a question from my side, which came from other colleagues as well before the presentation.
Yeah.
Maybe a difficult question.
Oh yeah, we'll see if I can answer it then. But
how do you see this all in 10 years time, 15 years time? What are we going to be looking at, in your view, in 15 years time, if in terms of the place of drone data within the data ecosystem?
Yeah, so
you mentioned opportunities and possible areas of improvement, but 10 years time, what is the world going to look like when we look at it from this aspect, from the drone data?
It's a great question, and obviously, whoever has the answer to that, that will be great. But I think, to some extent, you can have the answer partly by looking at former developments and looking ahead and seeing what's realistic. What I think we will have to a much larger extent 10 years from now is that we will have regulatory frameworks allowing for drones to fly beyond visual line of sight, so BVLOS flights. And that means that today the scalability of how drones are flying are still quite limited, in the sense that in many countries it's not allowed to fly beyond visual line of sight. So it limits the size of area that a drone can capture data from or transport something to. And what that really means is that today most countries have as their regulations that the drone flight needs to take place within line of sight. And that means that you need to have a physical pilot who can constantly see the drone. And that obviously limits the distance of where the drone can fly, and the physical person actually has to move along with how the drone flies. It's possible today in many countries to seek BVLOS permissions and to fly beyond visual line of sight, but it takes quite a lot of time. So I think in 10 years from now, it will be more standard operations that we do have beyond visual line of flights, and the drones will be operated even more autonomously than what they are today. I think also we will be seeing that the drones are out there and they're doing and performing multiple tasks at the same time. So obviously image data is one, but they could also be equipped with different type of sensors, air sensors, to collect air quality data and so forth. Obviously, you know, in some cases they could also be used to make deliveries, or they can be used to maybe in the case of, you know, mosquito breeding sites, they can be used to both determine the sites but also to spray the sites potentially. So I think that we will be seeing a more comprehensive system of drones being utilized in the society for different type of efforts, whereas we're now seeing more like one specific drone doing one thing in a bit of a limitation of what that drone can do. I think that will scale both in terms of the wideness of the flight and also the application area of that drone.
Thank you, Helena. Can you say something about the ethics of all of this?
Yeah, absolutely, and that's super important. And we've been also part of a lot of local surveys, both here in Stockholm, Sweden, and also in Malawi and in Rwanda. And I think it's quite fascinating to see that no matter where in the world you're located, it seems that the societies are very acceptable of drones if they know why the drones are there and if they know that they're contributing to society in a good way. If they don't know why the drone is there, then obviously they do see the drone as a hostile tool, you know, either being too close and getting, you know, taking too much of your privacy space, or obviously in countries where also drones obviously have been used in military operations, then that is taking the complexity level even further. I have not been part, or GLOBHE has not been part of using drones in countries where they have also been used as part of military operations. Obviously, the complexity in those types of countries are at a lot larger extent. So I think key here is information. Societies should know why the drones are there. And I know that there is a lot of innovation going on in terms of being able to have cell phone apps where you can detect. So if you know there is drones flying, you can see on that app why that drone is there. It's quite similar to how you can do that for regular air traffic or boats today. You can click on a boat that you meet that you're out sailing, and you can get information about that boat, where it's heading and who is operating that boat. But obviously, in order for that to be working for drones, we need to have certain mechanisms in place first. And one is the remote ID, which is being implemented for drones, meaning that each drone needs to have a digital ID so that it can be tracked to who owns the drone, and basically also be able to identify to some extent why it's there flying and for how long it's flying, etc. So I think to raise the awareness and get the local improvement is going to be key, no matter if we're talking about drone operations in Sweden, or if we're talking about them in Malawi, or if we're talking about them anywhere else in the world.
Thank you very much, Helena. Obviously, a lot of praise for the presentation in the chat box. So thank you very much to everyone. I don't see any other questions, but I wonder if Archana has picked up any questions or had questions from before the presentation.
Thanks, Attila. Actually, my question was, yeah, how do you see the future? So I think that was answered. So nothing else from my end. Thank you.
Thank you very much. Archana, I'll hand it back over to you to wrap up. But thanks once again to Helena for agreeing to be with us today. This was really fascinating. We should recognize, Helena, that for some of us, not many of us anymore, but for some of us, this is still a fantasy world to a large extent, especially for traditional data users who have not been very much exposed to technology this much. But still, everyone, and thanks to these kinds of webinars and your efforts in this area, it's becoming more familiar and real for everyone. So thank you very much for that too, for your contributions. So we are looking forward to the next 10 years to see how this will develop. It will be at least as equally fascinating, I think, the next 10 years as it has been in the last 10 years.
Yeah, I think so. I definitely think so. Even more, I would say. But yeah, I would also like to just really thank you for having me here today and for me to be able to present to UNICEF. It was a big honor.
Thank you, Helena. Archana, any last words before we break?
No, again, thank you from my side. And just a reminder that we will be taking a 1-week break with these webinars, and we'll be continuing the following week on May 20th at the same time. And the topic will be on geospatial data and household surveys.
Thank you very much, Archana. And thank you very much to all the participants, to all of those who took time to join us today, and look forward to see you, as Archana indicated, in 2 weeks. Thank you.
Thank you.
Thank you.
Bye, everyone.
That's great.
Bye-bye.